So could we start getting into kind of the space debris environment and kind of why it's becoming an increasingly larger problem?
Right. Well, it's really interesting because when it's a relatively new field. I mean, it's how we started launching human-made objects, and it wasn't even a thing, and it wasn't even a thing until they realized during the shuttle they were starting to get hits on the windshield, and that's bad, right? And so if you get a hole in your spacecraft, it means that all the oxygen that's inside the spacecraft will eventually go out of the spacecraft, and that's not really what you want. So therein lied started this field, and with just paint flakes hitting windscreens or windshields, and it's now blossomed into this huge field. When I first started, there was probably 200 of us worldwide that were studying, and now it's everywhere because when I was at NASA, we were looking at assuming there were going to be 75 launches a year, right? And that was when you would put one payload, maybe two payloads on one launch, right? So you'd get 75 new objects in space plus some rocket bodies in space. And now, I mean, if you look at, say, there was an Indian launch earlier last year, they put up 120 objects on one launch. And that just means that's that many more you have to keep track of when they die. That's that many more we've got to look at for space debris. So it's just, this problem is just going to continue to build upon itself. And so it's something that everybody and we talked about it in school, you got to learn how to play nice in the sandbox. And right now our sandbox is getting pretty crowded with toys.
Yeah, so then can we get into kind of the requirements? Well, I guess at least in the US, but I'm guessing there's also like international, or I guess each country has their own requirements, but kind of a deorbiting plan for if you're going to send something up, you have to have a plan for it to come back down.
Right. And what's interesting is there is actually worldwide agreed upon rules. So we have a group called the Interagency Debris Coordination Committee, and those are representatives from all over the world that come together and try and decide on as a group what these rules should be for mitigation. And then it's adopted by the UN, and it's through the UN Peaceful Uses of Outer Space, which is a really cool title, I think. And so every country that launches vehicles or launches spacecraft is supposed to follow these rules. So the rules really are in low Earth orbit, which is about 2,000 kilometers in altitude and lower. You're supposed to do something with your vehicle, with your spacecraft, rocket bodies, anything within 25 years of the completion of its usefulness or its activity. So if your spacecraft is active for 5 years, then 25 years from the end of that time, you have to either deorbit it, or you have to do something that's going to make it in the orbits in between Leo and Geo. You'd have to push it up into a certain altitude. So you have to do something with it. The problem is that's a really long time, right? And if you think about your career or my career, people are in these careers for 30 years, right? So you're talking about there's no policing that we can do really in this useful lifetime. So it's really, as I mentioned before, playing nice in the sandbox. Like, we want everyone to be able to actively participate. So in order to do that, we need to get rid of the stuff that's not an active spacecraft. There's different rules when you're higher up, because you can't naturally deorbit objects that are at the GEO regime, which is really high, 36,000 kilometers up off the surface. So they have to push it up higher and make it into what's called a graveyard orbit, about 300 kilometers higher.
Mm-hmm. Which, yeah, are the regulations, because as far as, a lot of people can send up CubeSats to LEO, but then I'm guessing that the regulations would be a bit tighter for GEO because it's kind of restricted, since if you want to be geostationary, it's just one area where you can be, where as far as LEO, there's a bunch of inclinations that you can be.
Right.
Yeah. So I guess, can you talk about the differences between the debris fields in LEO versus GEO?
Well, you hit on it right there by saying all the different inclinations and altitudes that you can be at in LEO means that there's debris all over. And when things come out, it now can get perturbed into an orbit that's everywhere. So in LEO, you kind of have debris coming at you in a bunch of different directions. Whereas in GEO, it's all really in that same line. And so if you leave something dead in the active GEO belt, that's really bad because it's not being corrected to stay in its little slot like everything else. Everything in geo has a very specific spot it needs to stay at. And so because of that, when debris is in geo, it's really even harder. As it propagates through, it's going to get out of the real tight geo band, but you don't want to have to maneuver away like you do in Leo away from objects. So there's a lot fewer debris in geo, fewer pieces, because there's fewer objects and fewer launches. It's more expensive to get out to geo. But we also then move up because the deorbiting aspect. So they put all the dead rocket bodies and dead spacecraft up in this graveyard orbit because of that. So the speeds are different too. That's the other big difference, because you're moving 7 kilometers a second, and those impacts of a direct collision in Leo is 14 kilometers per second, rather than in geo, it's 3 kilometers a second. And we call it in the field kind of a glancing blow in geo, where really what you get is a debris hitting you going like this instead of a direct collision.
Wait, for the geostationary transfer rocket bodies, do those, what are the requirements for those? I mean, because they're really elliptical. So do they have requirements of burning up or graveyard orbit?
Yeah, that's a great question. So it really depends on the semi-major axes. So it's the halfway point, right? If you remember. So the Leo to geo, you take those, or the closest point to the Earth and the farthest away point in the Earth, add those together and divide by 2. What that number is, it puts them in that category. So some of those objects can deorbit on their own after 25 years because they spend so much time in low Earth orbit, and it'll drag it down, but it takes a long time. The others will move into a graveyard orbit eventually in Leo and geo. And then the other real problem is that a lot of those are up there before these regulations and rules came into place, and they're just going to be there forever. And there's violators like an upper stage delta. You know, we just know it's violating, and we accept it's violating and move on, because there's not a lot you can do.
Right.
I can't go up there and just pull it down myself.
Yeah, that'd be expensive.
Yeah.
Yeah. So can we talk about the relative kind of the hypervelocity impacts and kind of what that means for creating new debris? Because materials, when they're going, kilometers, that many kilometers per second relative to each other, and they impact, they can vaporize. So kind of like the amount of energy that's involved and kind of what happens in those events.
Yeah, it's if you step back from the awfulness of a collision, right? If you can just look at the science of a collision, it's really super cool, because what happens is they're moving so fast, and that kinetic energy on that impact is so much that what happens is it can turn a solid metal into a liquid for moments, and you get these really cool structures from impacts that look like, and I always try and use this in class, you've seen those videos where milk drops and they do a slow motion, it creates this amazing crown of milk that gets, and that's what happens with the objects in space. They get this crater that has, because the metal has been liquefied at that point because of that heat and and the impact, that it makes this crown effect, and you get these really cool impacts. Now, the problem is if it's however thick that shield is, based on the diameter of the object, you can have different things, because there's a shock wave and a compression wave and a tension wave that's going through. And so what happens is where those meet, you can either vaporize the particle, or it makes a cookie cutter kind of hole through the shield if the shielding's not thick enough. And so these impacts are unbelievably complicated in order to model. But really what they're trying to do is, in order to save the spacecraft, you got to have a shield that's thick enough to stop the particle or vaporize the particle, and then, or move out of the way. But you don't want to make your shield so thick that you can't fly it, because mass is everything in space. So you have to kind of figure out some shielding techniques that will work. And in Leo, they shield spacecraft. In geo, there's no shielding, really.
So can we go into the shields then?